Hello, everyone, and welcome to this short mini-series on editing user resources with the Pollination Rhino plugin. And in this particular video, we're going to be covering how to create custom constructions and construction sets using the Pollination Rhino plugin. By the end of the series, we're going to be getting to the point of building your own libraries of constructions. We're going to use it as an example in this particular video. We're going to build a basis of design construction set that I plan to reuse on a lot of different projects. I'll give a disclaimer, like what I'm going to show you is informed by a lot of what I worked with in practice. So I did a lot of work in Boston for a few years working for an awesome architecture firm called Payette. And so I'm going to, as a sample for this video, put together a few construction sets for things that we were commonly using in that practice, with the hope that those of you watching will take the lessons learned in this series and apply them to your own office and create your own office standards. So let's get down to it. I'm going to just start by opening up the Pollination Rhino plugin and just launch a new instance of Rhino here. So this is loading up here. And specifically in this one now, we're going to create, what I would call the basis of design. And basically, it's our default assumptions for any new project that we typically would have. And we did a lot of work in and around Boston, so it's going to be informed by that particular climate. So let me just start now by very simply, this is a blank Rhino document here. I have the Pollination Rhino plugin open. And I can say specifically what we're going to do. I have here a window construction that I've actually, it's a detailed, real live window construction I've constructed in this program called LBNL Window. Specifically, this is a triple pane construction that we tended to use on a lot of projects. This is actually what I'm going to build a customized construction set with. Because more often than not in practice, and when I was in practice, we tended to use a code baseline for most of the constructions of the building. Because working in Boston, it has a very modern energy code. I think it's right now using the latest version of ASHRAE 90.1 or the 2019 version of ASHRAE 90.1. So a lot of the constructions were actually pretty, at least the opaque constructions are very thick insulation. And while you could increase the insulation, you weren't necessarily getting a lot of benefit from that. However, most of the window constructions in the latest code were still at the level where you can get away with a double pane construction. In my practice, when I worked at Payette, we tended to use triple pane as a basis of design, mostly because we had found that we could make a cost-effective argument for triple pane by showing that using such an insulated piece of glass, we could actually remove the perimeter heat and cut down overall costs. So almost on all the projects that we were doing, at least at the time that when I moved to working full-time on Ladybug a few years ago, all of our projects were pretty much assuming triple pane in Boston, but with code baseline assumptions for everything else. So this is what we're going to create here. So I'm going to go over to the, let's see, our energy constructions tab. And I'm very simply off the bat, I'm just going to make a construction of this triple pane window. And you can see, so this is actually showing you, I'll say this is the real basis of design that we typically use. This was like a Viricon specific type of product that I know our spec writers really liked because, one, it was very clear. You had really good visibility through it, so it looked good, but it also performed really well. It didn't cost too much. So we tended to use this again as like a base assumption. And so I'm basically going to copy this, and then our other glass just had clear pane stuff, and I have actually a full window construction here of like a fixed window, a typical fixed window that has some aluminum with thermal breaks in it, and these are particularly better thermal breaks. We did a lot of work on thermal bridging in practice. So if you look here, right, and I just hit calculate, this is the U factor, solar heat gain coefficient. These are the properties I'm going to try and match in the construction that I'm going to build here. So, all right, so we've opened up the construction manager in Pollination. Again, we just went to the resources menu and hit constructions. And, of course, we have a lot of constructions that ship with Ladybug tools, but I want to create my custom one, which is our real basis of design. So I'm just going to click on the add button here. And you can see that we can create detailed window constructions if we so desire from individual material layers. But I'm just going to choose this simple window option, which is a kind of a shortcut to just creating windows with based on essentially just the U value and solar heat gain coefficient that I mentioned there. And let's see, we're going to give this window construction a name. We'll call this like basis of design, or maybe we'll call it triple pane, just so we know what it is. And then maybe BOD for basis of design. And then maybe I'll put the word Viricon because we know that this is that particular basis of design product, and it was, I guess, VE12M. You could tell how much I applied this because I memorized the specific code for the product. But in any event, all right, so that's going to be our name of it. We want to match the U factor here, right? And that's exactly what we have in window here. Our U factor is 1.674 watts per meter squared Kelvin. So I'm going to put that in here. We'll do shoot, I already forgot it. It was 674. 674, right? That's going to be our U factor. And again, match our units here. You can always change this over to IP if you're a fan of the IP system. Our solar heat gain coefficient of this particular triple pane Viracon IGU I've constructed here is 0.311, so I'm going to plug that in. Right, that's a little bit lower solar heat gain than the default value that we have here. And then the visual transmittance was 0.524, which is actually not too far off here, but you know, I'll just match it for good measure here. Okay, 524. Right. So, all right. So now I've created this, right, I've got a name where I can easily identify it. And again, right, it's always good to pick a nice, unique name for your resources when you're creating them. So I'm going to hit OK, right, and we'll see that now this construction is going to show up as an option in our construction manager. It's something that I could apply to the, if I had a model open up in Pollination Rhino, I could apply this to the windows. But I'm going to hit OK for now because what I'm really interested in doing is not just creating this basis of design window construction, but I want to create a whole construction set that represents what my office would typically have done on a project. That includes this for windows, but also includes all of the thicknesses of insulation that are appropriate for climate zone 5, which is where Boston is and where a lot of my former office's projects were. So all right, so let me hit OK here. And maybe I'll just explain quickly in case there's some of you who have never heard this word construction set before. But construction set, these are very like kind of compound object. It's an idea we borrowed from OpenStudio. As far as I know, though, I don't think there are other energy modeling interfaces that have this type of object. But the basic idea behind it is that it not only includes the constructions like that you'd want to use, but it includes logic for how to deploy them across a model, right? So you can have a separate construction for your walls and, separate constructions for interior versus exterior versus ground contact walls, right? You have constructions for floors, for roofs and ceilings, apertures, which are just windows, and doors, right? So this is essentially what the underlying structure of construction set looks like in Honeybee and in OpenStudio. And so I'm going to create one of these that represents the basis of design in a climate zone, in the somewhat cooler climate of Boston. And you can see if I go over to our model resources tab here and then I look at our energy construction sets, I click on that, it's going to bring up the manager that shows you all of the construction sets that we ship with Ladybug tools. And you can see there's one like generic construction set, which has some defaults just to get things simulating if you don't have any construction set assigned to things. But most of these, we have a lot of things from the Department of Energy or NREL that have that we've shipped with Ladybug tools, so that you're able to at least have some starting assumptions that are at least sensitive to your different building construction types like steel frame, wood frame, mass, as well as the climate that you may be working in. Because obviously a hotter climate like climate zone 1, solar heat gain coefficient has got to be pretty low if you want it to be sensitive to the climate. Whereas right in a colder climate like climate zone 8, right, insulation is the important thing. Solar heat gain is less of a critical factor. So I'm going to start actually I'm going to search through these and I'm just going to find, let's see, 2019. Right, because that's the version of the code that we were typically using most often. My office is ASHRAE 90.1 2019, which corresponds to IECC 2021, I believe. And so, yeah, let's see, our steel frame. Steel frame was almost what most of our buildings were. We did a lot of laboratories and offices, right? So steel frame would be particularly good for that type of construction type. If it was residential, I might pick wood framed or something else like this. But I'm going to select this one, right? So this has a good set of starting assumptions for all the opaque assemblies. And what I'm going to do, I'm going to duplicate this construction set. Because I want to create a new one that has basically all the same assumptions for the walls, the roofs, the floors, etc. But I'm just going to change that window construction to have that Viracon basis of design. And let me see, what can I call this? I can call this, basis of design. And maybe I'll just clarify this is for climate zone 5. because that office did do a lot of projects that were outside of Boston, although most of them were kind of in that area. And then I could just say, let me see, maybe I'll also put 2019 just to note that this was ASHRAE 2019. And I'm going to use the same because I've been diligent about like making sure that this has a lot of information in it and that it's a really unique type of name. I'm going to use that also for the ID, which is how we're going to reference it. It's basically the idea is what you're going to see if you open up this construction set in OpenStudio or another interface, right? But I'd only change the ID if you're absolutely certain that you've come up with a unique name that you're not actually going to overwrite or duplicate by accident. So, all right, so this looks great. Let me see. We have walls. These are all IP units for walls and roofs here, but they seem pretty reasonable. And honestly, yeah, something like a roof with R32 in IP, which is what would that be over an R6 in SI? So this is like, I mean, this is pretty insulated. I mean, we could always up the insulation more, but like, honestly, at that point, that's not really, it's not going to change our energy use that much. It's a pretty good construction. But this window, right, this U value here, which is also an IP, this can definitely be improved. Like if there's a chink in the armor of this construction set, it's in these apertures here. So let me go. I'm going to change this to use our, let's see, our construction triple pane BOD VE12M. So I'm going to change all the exterior windows to use that. I could come up with a different construction for an operable window because those tend to be, slightly lower U value, in order to accommodate the hinging components and everything. But I'm just going to use the same one for the purposes of this video. We'll set the skylight. I mean, again, this is a skylight value that comes from the code, the ASHRAE 90.1 version. I'm going to change all skylights, exterior windows, and everything in operable windows to use this basis of design Viracon construction. And the doors, they seem good enough. I mean, these would also be chinks in the armor if we had a lot of doors in a model, but that typically they tend to occupy a pretty small surface area. So I think this is a pretty good representation of what I would used to do in practice by default if I was just running a particular project, where we'd assume that we're going to meet the building code, the latest building code, but we're going to do some extra stuff to the windows because, oftentimes doing those insulated triple pane windows would give us some extra benefit, like allowing us to remove all the costs of the perimeter heating system. In any event, okay, let me go. I'm going to hit OK. And we should now see showing up under here, right? We have a basis of design climate zone 5 2019. This is our, this is the custom construction set that I made, right? And we see the source of this is our model, right? So this is a construction set that is saved within the 3DM file that I have open here in Rhino right now. So what I want to do, I want to make sure that I save this file right now to make sure that I keep a record of that custom construction that I made and that construction set. But you see, by the end of this video, we're going to get to actually taking this construction set and sending it to our personal user library. So let me just say, let's see, I'll call this, this 3DM file basis of design standards, or BOD for short. And this is what I'm going to use. I'm going to basically build up some of the most common standards that I would have used in practice. We'll save them in this file, and then in the last videos we'll export these into our user library so that we can reuse them across several models. So that's it for this video. In the next one, we're going to be actually creating custom schedules and program types. And then we'll finally get to the fun part of saving these as a resource that you can reuse across multiple models. So thanks for joining this video. I'll see you in the next one.